Hey guys, today we're going to look at the fundamental theorem of calculus again, but this time through the lens of particle motion. So here's a couple of things to keep in mind. If you are integrating velocity from A to B, then that is equal to P of B minus P of A, where V of t obviously represents velocity and P of t represents the position of the particle. If you integrate velocity from A to B dt, then what that means is the actual numerical value represents the net distance that the particle travels over the interval A to B. If V of t does not change signs over that interval, then that also represents the total distance. Now, if you integrate from A to B the absolute value of velocity, then that represents the total distance that the particle travels on the interval from A to B, whether or not velocity changes signs. So let's put a couple of this into practice. We are told here that if the integral from -2 to 1 of v of t dt is equal to 5, and if the integral from 5 to 1 of v of t dt is equal to -6, and p of -2 is equal to 3, what is the value of p of 5? So first of all, we are given this interval from -2 to 1 and then 5 to 1. But if we reverse this order, this is the same thing as saying negative integral from 1 to 5 v of t dt is equal to -6. And this is because since the interval, we always want the lower limit to be on the bottom of the integral. So here we have -2 to 1, 1 to 5. We can put this together. This is the integral from -2 to 5 of v of t dt is going to equal to P of t, because when we integrate velocity, we get position, from -2 to 5, which we can write out using the fundamental theorem of calculus as P of 5 minus P of -2. Now, let's see how to rewrite this because we have these two values. From -2 to 1, that is the integral from, -2 to 5, -2 to 1 of v of t dt, plus the integral of 5 to 1, of 1 to 5. But we had to switch the order, so we would say minus the integral from 1 to 5 of v of t dt. And this is going to equal to P of 5 minus P of -2. Now we have a lot of these values, so we can go ahead and just plug that in. From -2 to 1, we know is 5, minus from 1 to 5, we have here is -6. So minus -6. So 5 plus 6 is going to equal to P of 5, which is what I'm trying to solve, minus P of -2, which is 3. 5 plus 6 is 11, is equal to P of 5 minus 3. So we would just have to add the 3 to both sides, giving me a value of P of 5 is equal to 14. So this is how we put together both the FTC and these properties of integrals into one problem. Let's do a couple more examples. We have here the velocity of a particle that is moving along the x-axis is given by the function v of t is equal to 3t squared plus 6. If the position of the particle at t is equal to 4 is 72, what is the position when p is equal to 2? So what does this mean? We are told that p of 4 is equal to 72, and we are looking for p of 2. So since I have p of 4 and I'm looking for p of 2, that means that I'm going to set up my integral from 2 to 4 of v of t dt. And this is going to equal to p of t evaluated from 2 to 4. So now let's plug in our function of v of t. So this is the integral from 2 to 4 of, oops, I don't know why I put an equal sign there. (3t squared plus 6 dt is going to equal to p of 4 minus p of 2. Now let's find the antiderivative of that 3t squared plus 6, which we add 1 to the exponent, so t to the third, and then divide the 3, so that would cancel the 3. So that is t to the third plus 6t. And now we're going to evaluate this from 2 to 4, and we know that p of 4 is 72 minus p of 2. Let's plug in the 4. 4 to the third is 64. Plus 6 times 4, which is 24. Minus, now we plug in the 2. 2 to the third is 8. Plus 6 times 2, which is 12. Which is going to equal to 72 minus p of 2. And now we just work this out. 64 plus 24 is 88. Minus 8 plus 12, which is 20, which is going to equal to 72 minus p of 2. 88 minus 20 is 68, is equal to 72 minus p of 2. So let's subtract this 72. 68 minus 72 is negative 4, which is going to equal to negative p of 2. So now we just divide negative 1 to cancel out the negative, and we get that p of 2 is equal to 4. Moving on to the next example. What is the total distance the particle travels on the interval 0 to 7? So remember that total distance, that is the integral of 0 to 7 of the absolute value of v of t dt. Now first we have to check if velocity changes signs. And the reason we do that is that there's really no way for us to integrate an absolute value. So if we're trying to figure out the integral of an absolute value, we want to check when it changes signs. And then we evaluate from 0 to where it changes, and then from that point to the end point, which is 7. So we're going to take our velocity function, which is the 3t squared plus 6, and it changes direction when t is equal to 0. So we subtract the 6 first, and we get 3t squared is equal to negative 6. Divide the 3, we get t squared is equal to negative 2, and then square root. But when we square root, we end up with the square root of a negative, meaning that velocity never changes signs in this case. So the integral from 0 to 7 of the absolute value of v of t dt is going to equal to just the integral from 0 to 7 of v of t dt, since our function never changes signs. So that means that the net distance is going to equal to the total distance. So that's essentially what I have written here. Total distance is equal to net distance. So now we already know the antiderivative of v of t, which is the t cubed plus 6t. So we can evaluate that from 0 to 7. So when we plug in the 7, we get 7 to the third, which is 343, plus 6 times 7, which is 42, minus, when I plug in 0, everything will end up being 0, so 0. So our total distance here is 343 plus 42, which is 385. And since we don't have any units, we don't have to worry about it. But if we did have units, like let's say feet, then it would be 385 feet. But there are no units, so just 385. Now let's look at a calculator question. We have the velocity of a particle that is moving along the x-axis is given by the function v of t is equal to 0.5 e raised to the t times t minus 2 to the third. If the position of the particle at t is equal to 1.5 is 2.551, what is the position when t is equal to 3.5? So again, here we're looking for a p of t value. We're looking for p of 3.5. We are told that p of 1.5 is equal to 2.551. And again, we're looking for p of 3.5. So since we have this position value and we're missing this one, that means that we can set up our integral of v of t, since it equals to position, from 1.5 to 3.5 of v of t, which is the 0.5 e raised to the t times t minus 2 to the third dt. And this is going to equal to p of t evaluated for 1.5 to 3.5, which, using the fundamental theorem of calculus, we know is p of 3.5 minus p of 1.5. The calculator will give us this value. So we can just go to the calculator. We're going to go ahead and graph our velocity function. So 0.5 e raised to the t, or x in this case, times x minus 2 raised to the third. So now let's graph that. And let's find the value of that integral. So we go to the second calc menu, option 7. Our lower limit is 1.5, and our upper limit is 3.5. And we get a value of 15.9191. So the integral is equal to 15.9191, and that's going to equal to p of 3.5 minus p of 1.5, which we know is 2.551. So in order to solve for p of 3.5, we just have to add the 2.551 to both sides, which gives us a value of p of 3.5 is going to equal to 18.4701. Now for this next part. What is the total distance the particle travels on the interval 1 to 5? So I even have here to calculate total distance when there is a change in direction. First, we have to determine the value of t where velocity changes signs. We will call that point C. So just to set this up, total distance is the integral from 1 to 5 of the absolute value of v of t dt. Now we're going to check when velocity changes signs. So we're going to go to the calculator here again. I'm going to clear this out. And, well, it still has the shaded region. That's okay. I'm looking for when v of t is equal to 0, which you can see is somewhere around here. So we're going to go to the second calc menu. We click on the option 2 for 0. It's going to ask you for the left bound. So I'm going to go over to the left of that 0. And you can also tell when it's to the left by looking at the y value. You see that it's negative. So it's below the x-axis. And now I want to go above the x-axis. Now the y is positive, so this is above. Press enter again. And we get a value of 2. So that means that v of t changes direction or changes signs at t is equal to 2. So when we set up this integral for total distance, that's going to be the absolute value from 1 to 2 of v of t dt plus the absolute value of the integral from 2 to 5 of v of t dt. And I put absolute value because, remember, that distance is always going to be positive. And even if it goes in, it is going to be going back and forth, we're going to get a negative distance at some point. And we just have to make sure that we put the absolute value so we can get that total distance. So I'm going to come here now to my calculator, and now I'm going to integrate from 1 to 2. So we go again to the second calc menu, option 7, lower limit is 1. Upper limit is 2, and we get negative 0.4209. which again, absolute value. So absolute value of negative 0.4209 plus, now we're going to integrate from 2 to 5. So again, we'll go to the second calc menu, option 7, 2 to 5. And this gives us 912.6461. So now we just have to add these together. So this is positive 0.4209. So let me go to my calculator once more. I'm just going to do this here. 0.4209 plus 912.6461. And that gives us the value of 913.067. And this is my total distance. Now let's look at a couple of graphs. The graph of the velocity measured in feet per second of a particle moving along the x-axis is pictured below. The position p of t of the particle at t is equal to 8 is equal to 12. So this means that p of 8 is equal to 12. Use the graph of v of t to answer the following questions. So here we're looking for the position of the particle at t is equal to 3. This is like the questions we've done before. We have p of 8, we need p of 3. So that means that we're going to set up our integral from 3 to 8 of v of t dt, which is going to equal to p of t evaluated from 3 to 8, which again, we know based on the FTC that this is p of 8 minus p of 3. So I'm going to come here now to my graph because my graph is going to tell me what the integral value is. We are going from 3 to 8. So we have this trapezoid here, and we have this triangle below. The area of the trapezoid will be positive because it is above the x-axis. So we can do 1/2 times the height of the trapezoid, which is 5, times base 1, which is 1, plus base 2, which is 3. Minus, now the area of the triangle because it is below the x-axis. So 1/2 times the base, which is 2, and times the height, which is also 2. And this is going to equal to p of 8, which is 12, minus p of 3, which is what I'm trying to solve. So here we have 1/2 times 5 times 1 plus 3. 1 plus 3 is 4, times 5 is 20, and half of 20 is 10. Minus half of 2, these will cancel, so minus 2 is equal to 12 minus p of 3. 10 minus 2 is 8, and that's going to equal to 12 minus p of 3. If we subtract the 12 to both sides, we get negative 4 is equal to negative p of 3, which then we would divide by negatives to both sides to give us that p of 3 is equal to 4. So that is the position of the particle when t is equal to 3. Now we want to know what is the acceleration when t is equal to 5. Now acceleration is the derivative of velocity. So a of t is going to equal to v prime of t. Therefore, a of 5 is equal to v prime of 5, which if I go here to 5, this is a line segment, so the derivative is going to equal to the slope of that line, which the slope of this line, it goes 1, 2, 3, 4, 5 down, so negative 5 over 2. And I forgot units here because we are given units that velocity is in feet per second. So this would be in feet per second squared. And this right here, this position that we did earlier, this is 4 feet. So this is, going back to part B, this is the acceleration when t is equal to 5. Lastly here it says, what is the total distance the particle travels over the entire interval? So this entire interval, that's from 0 to 10. So if I want to get the total distance from 0 to 10, that is the absolute value of v of t dt. Which, when we integrate that, we see that here velocity changes at t is equal to 6. So we have to get the absolute value of the integral from 0 to 6 of v of t dt plus the absolute value of the integral from 6 to 10 of v of t dt. So from 0 to 6, I'm going to change colors here just so that we can see. We have a trapezoid here. And this is a positive trapezoid, but it's still, we're going to put in the absolute value. 1/2 times the height, which is 5, times base 1, which is 6, plus base 2, which is 2. Plus, now I'm going to do the absolute value of this interval here from 6 to 10, which is negative 1/2, since it is below the x-axis, but again, it's absolute value of the base, which is 4, times the height, which is 2. Here we end up with 1/2 times 5 times 6 plus 2, which is 8, plus 1/2, so I'm taking out the absolute value, so I'm making a positive of 4 times 2, which is 8. If we evaluate this, this is 8 times 5, which is 40. 40 divided by 2 is 20, plus half of 8, which is 4, which gives me a total distance of 24, and then don't forget the units, which is feet. Now we're going to look at a chart. It says here, the table below shows values of velocity in meters per second of a particle moving along the x-axis at selected values of time in t seconds. What does the value of the integral from 0 to 18 of v of t dt represents? Now, since we are evaluating 0 to 18, this represents distance. Now, whether it's net distance or total distance depends on whether velocity changes signs. If we look at the velocity values here, they are all positive. So we can say here that since v of t is greater than 0 over the entire interval, the particle is always moving to the right. Therefore, the integral from 0 to 18 of v of t dt represents total distance. Now, it's not actually asking you to evaluate for that distance, it just asks you for what it represents. So that's all we would need to write for that. Now here it says, using a midpoint Riemann sum of 3 subintervals, estimate the value of the integral from 0 to 18 of v of t dt. So if we need to use a midpoint, that means that we need a point in the middle between two values. So I would go from 0 to 6, from 6 to 12, and then from 12 to 18. So that gives me those 3 subintervals, and I would be using the midpoints, which is what's in between. So if we look here, every interval is exactly 6 units away. So all of these rectangles have a base of 6. So the integral of 0 to 18 of v of t dt is approximately 6, since the bases are the same. And then the function values that we would use, which would be v of 3 plus v of 9 plus v of 15. Now we're just going to plug in those values. So 6, v of 3, which is 2.7, plus 1.3, plus 1.7, which if we add all of this together, it gives us 6 times 5.7. And if we multiply that, we get a final answer of 34.2, and then our units, which is given in meters, since this represents distance. Next part here, it says, on what interval is the speed of the particle decreasing, and justify your answer. So first of all, when do we know that the speed is decreasing? The speed is decreasing when v of t and a of t are different signs. We already know that v of t is positive over this entire interval, so we need to find when a of t is less than 0. So a of t is less than 0, right? So we're looking for when a of t is negative, so that means that the speed is decreasing. When v of t is decreasing, since it is the second derivative, that means that the first derivative would have to decrease. So we're going to look here, 2.3 to 2.7 is increasing, 2.7 to 2 is decreasing, so we're going to start here at 3, decreasing, and then it decreases, and then it decreases, then it increases at 15. So the interval here would be from 3 to 12, because that means that acceleration is negative and velocity is positive. So the speed is decreasing over that interval. Now it says here to find the average acceleration of the particle on the interval 3 to 9. So average acceleration, that's like the mean value theorem, which is when we do v of 3 minus v of 9 over 3 minus 9. Remember that average acceleration or average anything is the slope of the secant line. Now v of 3 is equal to 2.7 minus v of 9, which is 1.3, over 3 minus 9, which is negative 6. 2.7 minus 1.3 is 1.4. Divided by negative 6, if we divide this, we get a final answer of negative 0.2333, and then our units, which would be meters per second squared, since this represents acceleration. Now let's look at one more FRQ, and this time it is a full FRQ dealing with particle motion. We have here that a car is traveling on a straight road with velocity 55 feet per second at time t is equal to 0. For t is between 0 and 18 seconds, the car's acceleration a of t in feet per second squared is the piecewise defined by the graph given, so this is a of t. Is the velocity of the car increasing at t is equal to 2, and justify your answer. So velocity is increasing when acceleration is positive. So at t is equal to 2, since velocity is greater than 0, then that means that the acceleration, since acceleration is greater than 0, then that means that velocity is increasing. So we would say here that a of 2 is equal to v prime of 2, which is equal to 15. So since a of 2 is greater than 0, then that means velocity is increasing. Moving on to part B. At what time interval from 0 to 18, other than t is equal to 0, is the velocity of the car 55 feet per second, and why? So here's the thing. If we're trying to figure out when the velocity is equal to 0, or rather, when is the velocity equal to 55 feet per second, then that means that the integral from 0 to some value, we'll call that c, of a of t dt has to equal to 0. Now, when does this equal to 0? When the integral, right, has positive, positive area and negative area that will cancel. Here we have this trapezoid with a base of 3 and a height of 3 and another base of 1. So if I were to kind of mirror that over here, since we see that it is almost the same, we have the same trapezoid that ends right here. So that means that C is equal to 12 because this area here would cancel with this area here. So this means that the integral from 0 to 12 of a of t dt is going to equal to v of t evaluated from 0 to 12, which is v of 12 minus v of 0. And since they're equal, since v of 0 is equal to 55, that means that v of 12 must also equal to 55. So the time here would be t is equal to 12 seconds. Over here it says, over the entire interval, what is the car's absolute maximum velocity and at what time does it occur? So absolute maximum can occur at the endpoints, and in this case, at t is equal to 6, because that is a critical number of acceleration. And we know that a critical number of acceleration could be a possible extrema for velocity. So now, according to EVT, we know that, like I said, that our absolute maximum can occur at the endpoints and that critical number. So first we need v of 0, which we are told is 55 feet per second. Next, we would need v of 6, which is our critical number. Now, in order to find v of 6, that means that the integral from 0 to 6 of a of t dt is going to equal to v of 6 minus v of 0. Now, we can do this 0 to 6 is this trapezoid, which we can find, and then to v of 6, oh, that's just it. So from 0 to 6 is the area of that trapezoid. So 1/2 times 1, 2, 3, that's the, times the height, which is 3. Wait, 1, 2, 15, 15. We have to pay attention to the axis there. That's the height, times base 1, which is 3, plus base 2, which is, not 3, 6, because this is going by 2's, plus this one here, which is 2. And that's going to equal to v of 6 minus v of 0, which is 55. So this gives me 1/2 times 15 times 8. Half of 8 is 4, and 15 times 4 is 60. So this trapezoid is 60 is equal to v of 6 minus 55. So to get v of 6, we just add the 55 over. So v of 6 is equal to 115 feet per second. Then lastly, we need from 0 to 18 of a of t dt in order to get v of 18, which v of 18 minus v of 0, which we know is 55. Now, if we look here, right, the majority of the area from 0 to 18 is negative. So that means that this area is going to be predominantly negative. So 0 to 18 of a of t dt is going to be less than 0. So I already know that this is not going to be my absolute maximum. And in fact, the absolute maximum would be the 115 feet per second. So this is the max velocity, since it is bigger than 55, and since it is obviously bigger than a negative. Now over here in this last one, at what time interval is the car's velocity equal to 0? And justify your answer. So in order to figure out when it equals to 0, that's kind of hard to do, especially when we only have a of t, and we're trying to find when v of t is equal to 0. So we know that we're going to have a minimum right here at t is equal to 16, right? Because this is the acceleration going from negative to positive. Now, why did I point this out? Because if I can find the minimum, if I can see that the minimum is a negative number, then that means that velocity is equal to 0 would be somewhere else. But if I get that the minimum is a positive number, then that means that there is no velocity for when v of t would be equal to 0. So let's find that out. We have that t is equal to 16 is a minimum. So we can find v of 16 by doing the integral from 0 to 16 of v of t dt, which is going to equal to v of 16 minus v of 0, which is equal to 55. So we have here, I can find this, what's it called, area, right? So we already know this area here, that's what I found up here to be 60, right? Because that's the area of that trapezoid. So the area from 0 to 6 is 60 because of the trapezoid, minus now the area from 6 to 16, which is another trapezoid. So that would be 1/2 times the height of the trapezoid, which is 15, times the base, which is 2, 4, 6, 8, 10, plus 2, 4. And that's going to equal to v of 16 minus v of 0, which is 55. So this gives me 60 minus, now half of 14 here, that's 7. And 7 times 15 is 105. And that's going to equal to v of 16 minus 55. 60 minus 105 is, what is that equal to? Negative 45. And that's going to equal to v of 16 minus 55. So if I add the 55, I get that v of 16 is equal to 10. In this case, feet per second. So I just found the minimum, which is 10. And this minimum is greater than 0. So that means that v of t, it will never equal to 0 over this interval. Because if the minimum is 10, then there is no way that it can go below that. And that's the FTC and particle motion.